Hi, it's Reda here. In today's video, we're going to talk about complex number. But in today's video, complex number, all is going to be about theory. It's like we need to answer the theory part of it. And in the next video, we're going to talk more about the practical part of it. First, we have to start, before we start with complex number, just a slightly bit reminder what we used to use in math. We use a lot in math and we still, which is real numbers. Real numbers, we refer them to A. Or sometimes we use natural numbers as an example. There are a lot of types of numbers, but basically in all exercise or in our A level, we use a lot R, which is real numbers, or natural numbers. But in here today, complex numbers, we refer them to Z. How can we write any complex numbers? Complex numbers is in real numbers here, we can say x equals -3, square root of 5, etc., etc. But in complex numbers, we write Z equals A plus B times I. A and B, what are they? Belongs to A. Both of them goes back to A and B. And therefore this I in here equals square root of, this is the interesting part, -1. Usually in A, this formula doesn't exist. It's totally wrong in number R, real numbers or natural numbers, because square root of any number has to be positive in here. But in complex numbers, we can write square root square of a negative number and refer that to I. And basically in here, if we said I is the square root of -1, then I square equals square root of -1 square and equals -1. And this is the interesting part. Basically, square of I equals -1, which is in real numbers. What we knew in the past in maths is totally wrong and it's impossible. It has to be positive in here, because in here we got square or power 2, but in here equals -1, and this is what we call them complex number, because they're slightly bit complicated. Then let's move on. I power 3, which is equals A power 2 times A. A power 2 equals -1 times A and equals -A. Then A power 3 equals -A. And you can move forward by A power 4, A power 5, and move on using A square and A equals square root of -1. Now, we knew that complex number, we write it this way, A plus B I. Then now, what we can do in here, we've got A and B are real numbers, and then I equals square root of -1. Now, there is different types of what we can define, complex number before we move on. A complex number, any complex number got this way here, like this. Which is in here, we call the real number. This is the complex number, basically Z. Got real number and imaginary number. We refer real number to A, imaginary number to M. Basically in here, what's the real numbers? And this is the formula, mathematical formula of a complex number. What is the real number? A real number is A, and then imaginary number is B. And how can we write this? A and B belongs to R. Still, yeah, they are real numbers. Then if you want to take off the real number from this formula here, what we can write? We write real. We refer just to RE. You can write real, but RE is better. Of this formula here, A plus B times A equals A. And imaginary number of A plus B equals B. As simple as this. This is the real number and this is imaginary number. Now, if you got two complex numbers, let's say Z1 equal X plus Y I, and then Z2 equals X2 plus Y2 y, or y2 times a. Then to add them two numbers, we can use basically is the same as any other number, plus or addition and multiplication. For the addition, what we can do, we can add the real number with the near real number and imaginary number with imaginary number. It's basically equals x1 sorry, plus x2 plus y1 plus y2 a. We can't add the real number with imaginary number. They are completely different in different groups in here, as you can see in our formula here. Just write it to understand things properly to make it simple for you. Now this is basically z1 plus z2. But if you want to say now the multiplication here is quite simple and straightforward. Basically what we have to do is we have to make a good distribution. I'm just gonna make some space in here, and you're gonna make just simple distribution, which is gonna be that simple and easy. In here we can make it just this way in here. Sorry, we said z1 equals x1 plus y1 I say 2 x2 plus y2 I. We want to calculate the multiplication z1 times z2. We've got, this is the real number, imaginary number, real number, imaginary number. In addition, we just use real with real, imaginary, but in terms of in here multiplication, what we can go for is just to make it simple, 1a times x2 plus y2 sorry, I. And then what we have to do in here is just basically make a good basically distribution, x1 x2 then plus x1 times y2 I plus y1 a x2 plus y1 times y2 a square. I square here, x1 plus times sorry x2, done with this. And then we're gonna take just a real number put on its own. This is not real, this is a real number, not real, this is imaginary number, this is imaginary number, here this is a real number. Why? Because a square equals -1. We can write this minus y1 times y2. This is the real number, plus, and then we've got x1 times y2 plus y1 x2 times a. And then this is the real number and this is the imaginary number. And this is not the problem, but basically how to do the multiplication between two complex numbers. One more thing we have to mention here, in terms of if we say, let's say this is the real number we've got. In any other number, just to, instead what I'm gonna talk about, in let's say in real numbers, we've got here real numbers, as simple as this. We've got here, let's say middle is 0. We've got here +1. The opposite number in here, we call it -1. As simple as this. We've got a lot of infinity of numbers, but let's say here, this is real numbers, by the way. From 0 to 1, we've got infinity of numbers, but let's say we take it just 1, or here we say, let's say 2 plus 5, 2.5. The opposite number here of 2.5 in the negative number, which is -2.5. As simple as this. Then, if we said complex number, as we've spoken before, we said that complex number, they are similar than real numbers, not real numbers, but they got their own rules or their own formula. Then, there is another part of complex number, which is negative side as well. But how can we write this? We call it conjugates. Basically, if a real number, a complex number, we call it z equals a plus b I. Then conjugate number, we write it this way. You can write it the way you want, but write it usually this way, a, and here just kind of small start, equals A, real number remains the same, but here we said minus B I. This is the conjugate number. Basically, if we said in the graph in here, 0 in here, we've got here Z, and in here we've got Z star. This is the conjugate number, or the opposite number. It's exactly same as in a real number, but we call it here a complex number. This is basically what we call the conjugate number. All right, what we said, just to recap slightly, complex numbers are the same as any other numbers. We write them this way: Z equals B, A or B or whatever real number plus imaginary number times A. And then A and B, and a real number and imaginary number are reals. Then we've got A in here is square root of -1. This is what we call them complex number, because they got this thing in here which is slightly bit. We can't write this in a real number, because in maths, in real number we can't write this. It has to be positive. But in complex number we can write it -1, and we call that I. And then I square equals -1. Then I squared equals -1. Again, we make it slightly bit different, because in real number it has to be positive, but in here in complex number it's negative. Then we said in every single complex number we got two parts, which is real number and imaginary number. If you want to add two complex number, you have to add real with real, imaginary with imaginary number, and you got your formula. Slightly bit complicated formula, but it's gonna be real number plus imaginary number again. And then in here we said there is always in every single number or group of numbers. Again, before we went in here, we spoken about duplication, multiplication. Here what we have to do is just make it, it's like basically distribution, and then you end up having this formula again, which is real number plus imaginary number. But you can make duplication between reals and imaginary numbers, not like the addition. But in here, what we spoke at the end, we said in real number in here, we've got basically the positive side and negative side. And for every single positive number, we've got its opponent or other number, same but in a negative side. In real numbers in here. But in complex number, because we said they are same as any other number, basically for every single complex number in here, positive, there is another side of the same complex number, but it has to be in a negative side, technically, just to make it understandable. And we call that Z power or whatever. You write in here start, because with this start in here we can show that this is the conjugate. We call it the conjugate. And how can we write this? Again, it's A minus B times I. And then, but in here you have to be really careful, because real number remains the same, but the imaginary number, it changed from plus B to minus B. This is all for today in terms of the theory part of it, which looks really easy and simple, but you have to take it step by step. We don't want to bombard you with a lot of information. In the next video, we're going to talk more about how to use it in real, basically with more examples and mathematics functions, and how to use this complex number. And the more we use, for examples, exercise and problems to solve, the better it gets. Stay tuned. Let me know if you need any questions. I'll start doing more practical things by yourself, and always here for help. Speak soon in the next video.